Hello, DrRosmaini again here. So let's continue on part 2 for chapter 5, the foundation of business intelligence, basically database. Okay, this is an entity relationship diagram that show the interlinking between entities. These are the entities like supplier, parts, line item, and order. These are four entities. So in the logical diagram, how these four tables are interrelated. So basically in part 1, I have explained the relation between supplier table to part table and to order table, and then later connected through a line item table. So in the logical diagram, so these supplier, part, line item, and order tables are all interrelated with this logic. So basically, this supplier information can access information at the parts table, and parts table can access item or information in the line table. However, line item cannot access information in order table. Instead, order table can access information in the line item. In other words, supplier provides parts, and then that part is ordered through line item, and that line item belongs to the order. So these are the entity relation diagram, how those four tables are very much linked or related to each other. So it's time to discuss to the next topic, which is part of the component of database, how we can better make use of databases. Basically, databases contains a lot of data, large data or big data. So these data, because they are so big, they are normally in the form of unstructured or semi-structured data, because you could retrieve or collect all this data from the traffic of the web, from social media platform, for example, like Facebook, Insta, Twitter, and also from sensors like from the environmental sensor in the cities, for example, like an environmental sensor in the form of particular uh, in the air, particulate in the air, and also from the weather and so on. So since these data are very big, so they must be organized, all right? They are big. It could be at the scale of petabytes or exabytes of data. So these data are too huge for typical database to process it. So we have to make use of certain software or application in order to make use of this big data, so that it creates meaning and value for managers to make better decision. So database like from Amazon, and your purchases by using credit card and so on. So these are contributing to the availability of big data in current decades. And from big data, basically, you can process it in the approach of business intelligence. So there are some tools available for businesses to basically create intelligence out of this big data. So some of the tools available are data warehouses, data marts, using application to process big data like Hadoop software. You could also use in-memory computing based on the RAM's content, and also analytical platform, for example, like R programming. So let's discuss on first tool is data warehouse. Well, the name says by itself that this warehouse stores data, which is current data, asynchronous data, and also historical data from many operational transaction. For example, from the TPS, transaction processing system, so or from any purchases that you make online. So these data are consolidated, and later they are being standardized in terms of format or in terms of its structure. So this data basically static. It cannot be altered. However, you can analyze the data, and you can create a standardized reporting tool in order to understand what the data is reporting. The second tool called data marts. Data marts is basically a subcomponent of data warehouse. So it could summarize and focus a portion of the data by using a specific category of users. And normally it focuses on either on single subject or single category of business strategic unit. So this data mart is more focused in comparison to data house, which is more generalized. Let's take a look on this diagram. How does the component of the data warehouse basically interact and related to each other? So as I said earlier, you could use a software application like Hadoop in order to process, categorize, and analysis the data. So this Hadoop, for example, in the data warehouse like from Maybank. So at Maybank server system, it has operational data. It has also transactional historical data that you have purchased through Maybank. It has machine data, data from its website, maybank2u.com. Could be audio and video data, and also external data like from data from supplier and also from customer. All this data could be contributed to Hadoop, which is analytical software, and this Hadoop will access the data warehouse inside the Maybank server. And this data warehouse also got data mart, which is a specific application of transaction, for example, in which engaging users for their queries, report, and also for managers to see their dashboard. This data warehouse also are linked into the users that are using the data inside the data warehouse. For example, users, employees of Maybank that are using queries or search for information, Maybank employees that generate reports, online analytical processing on OLAP, and also data mining by Maybank employees. And this could be engaging analytical platform, for example, like R programming, and they are accessing data from data warehouse at the same time incorporating analytical tools by Hadoop so that they can extract the trend and also give projected reports for the managers at Maybank. So these are all the interrelated linkage of components of a data warehouse in which to make better use and create more meaning on the big data platform. As I told you earlier, Hadoop is an application software, a software system that enable programmers or business and analytical executive to do processing parallelly in the distributed manner for big data collection in order for them to interpret its meaning. So Hadoop basically produces analytical report in the form of this kind of graphical diagram. For example, it could be in the histogram diagram, it could be in this line diagram, and these consolidated data are basically derived or programmed by Hadoop so that managers can have a better value of this data so that they can decide more efficient and effectively. Basically, Hadoop is converting this huge digital data in the form of one and zeros, program it into a particular specific format of result that the user wanted, and project it into the dashboard or into the terminal so that the manager can see, analyze further, and also to make subsequent decision. So that is basically what Hadoop software analytical platform does. Databases also can use in-memory computing, basically online asynchronous data that is available on the online, for example, during transactions, so that they can basically analyze the transaction so that perhaps they could reduce the hours or days of processing in terms of purchasing transaction from long hours into second or make it faster. So in such a way, for inline memory computing to be executed, it must require the optimization of the hardware. Another tool which can be used is analytical platform, which is high-speed platform using both relational and non-relational tool for a large data set as executed by software Hadoop to process big data. Analytical tool basically using relationship and patterns and creating trends so that they could consolidate, analyze, and provide access to very big data for users to make better and more accurate decision, in which they can make use of this multi-dimensional data analysis or OLAP, or data mining, text mining, or web mining. Those are another analytical tool which are available that we can make use of data and information that exists in our database. OLAP. OLAP is basically a synchronous transaction analysis that can be done online. It supports the multidimensional array of data, viewing data using multiple dimension in which it can be viewed in many layers and in many perspectives. For example, this is a multi-dimensional data model. For example, this is a database. So it has 3 dimensions. For example, the first dimension is product, which are the product that your company are supplying, like nuts, bolts, washers, and screws. And you want to monitor its sales projection or target actual sales within the region of East, West, and Central. So in which how many nuts we are supposed to be selling, and what is the actual volume that we have sold at perhaps region West. So this is how we could see the 3-dimensional data for managers to make decision. So this is the multi-dimensional data model. Another analytical tool is data mining. Okay, in data mining perspective, basically, computer could analyze the hidden patterns, relationships in data sets. For example, customer buying patterns at Amazon. For example, I go to Amazon and I'm looking for books on data analytic. Perhaps I have found this book, Big Data Analytic with Hadoop Tree, right? So I have decided to buy this book, and later I pay, I execute the transaction, and within 10 or 12 days, this book come to my home. So in this kind of data mining, basically at Amazon, computer programmers can do association, sequencing, classification, clustering, and also forecasting by using Amazon big data warehouse that they have available. So from that big data warehouse availability, but after purchasing this big data analytic book, perhaps in the next few weeks, Amazon will suggest me another relevant bestseller book. For example, this Python data analysis. Python is another software that programmers use to analyze big data. So this book is very much related to this book. As such, Amazon could suggest me newer book later after a few days or few weeks, suggesting that there is another bestseller book in which the same category that you have bought perhaps 2 or 3 weeks ago, so that the system is suggesting me a new one. So this can be executed through data mining of associations. Text mining. This is another typical of a big data analytical approach that we normally in business use. For example, data programmer could extract key element of large unstructured data from your emails, from call center customer feedback in terms of, for example, complaining or quality reports or customer feedback, some difficulty in using the product, computer programmers also can use legal cases information in order to execute text mining, patent description, service report, and so on. So these are few approaches by the approach of text, mining the text to create values and new meaning for manager to decide their subsequent business operation. The third analytical approach is web mining, in which the website itself is basically being evaluated or being analyzed for useful patterns, right? Or they can make use of the mining of the web pages, its structure and linkage to other web pages. So these are very much common in current internet world, the web mining, because one website is very much linked or related to other websites. So bottom line is webs and database are very much related. I would say web is the linking of the computer databases all around the world. So basically these web were powered by web server, and this web server, because it is a network, so it is very much linked to other web server, to the other website, and all website basically are connected to databases. So let's take a look at the linkage between internal databases to the web. So let's give an Amazon company as the example. So say at Amazon.com, here am I, a client at the web browser like Google Chrome or Explorer. I want to search for a book at titling Big Data Analytics. So I have to go to computer terminal with appropriate linkage or network to the internet. And this internet will allow me to be linking to the Amazon web server. And inside this web server, basically there is a software server, for example, for search, for purchasing books. So that is at the level of application server. In that application server, I will search or type the book title that I need. For example, Big Data Analytic, and then I press enter. So this database server will allow me to search the content information inside this database, and of course later the system will list me few books which are relevant or which are basically frequently searched in on title Big Data Analytic, and from there I will make my decision to purchase, make payment, and get my book. All above all, basically all these data resources must be managed properly. So as such, companies and organizations need to establish its IT policy or information policy. Equally same as our university UTHM, it has its IT policy, in which the organization engage or decision on what kind of rules, procedure, how to share roles, and how to manage this data inside this big database of the organization. So as such, this data must be administered in the way that what kind of a procedure must be there, how to access information, who could access information, and at the same time, the data must be governed. So the governance must be clear as far as this is how to deal with policy and processes for managing availability, usability, integrity, and security of data, and all these are one of the strong requirement of any organization. That's why in this database administration, you need to create and maintain the database, and to better govern these databases. That's why we have this layer of information access, in which not all people can also access all data. For example, dean and deputy vice chancellor can access higher layer information, and the lower level, for example, like administrator, can access only their level of accessibility for information. That's why we have password, we have particular scheme and mechanism to access data within our own database system. Okay, so data must be managed so that it can be used properly, and managers can decide efficiently and effectively. However, data must be ensured its quality level. So people say garbage in, garbage out. So if you put data discriminately, you put data inaccurately, so you could end up have a wrong data. You could have a wrong report. So data must be kept in a high quality so that it doesn't have redundancy. Data must be consistent in terms of its format, in terms of its approach in keying in, and data must be free from any faults. So as such, we have data quality audit. So for prior data can be keyed in, so it must be audited, or it must be inspected, or it must be filtered, so that we can have good data cleansing, so that only good data can enter our database, so that we can have a good result when we do the query on the database. Okay, my student, that will wrap up for my lecture on Chapter 5, Foundation of Business Intelligence. I hope you have found it to be useful in understanding this chapter. I would like to thank you again on your attention. So, thank you. We urgent here. Okay, see you later in the next chapter. Thank you and goodbye.